So we've got our two gardens here. We just labeled the length and the width of the first one, which would be the piece family technically. As X and Y, we don't know what the length is. But we do know that the other garden, Brock's garden, is 2/3 the length. And then it's also 3/4 the width. So we're going to do 3/4 times whatever the width is, which we'll call Y. How do the areas compare? So the area here is going to be XY when you multiply. And here when you multiply, take a look at what you're going to get. You could simplify early if you wanted to. You could write it out. You could do 2/3 X times 3/4 Y. And when you multiply straight across, you're going to get 6/12, which is 1/2. So it's going to be 1/2. Or you could cancel these 3's early and then cancel the 2 and the 4. And so the 2 and the 4 would become a 1/2. And then that's all you're left with because the 3's canceled out. So either way, you're going to take it one step at a time. You're going to get 6/12 XY. If you'd like to put it on the top, you can. So basically 1/2 XY compared to this. And so to answer the question, how do the areas compare? So this one is technically the Brock family. So Brock's is 1/2 the size because this is XY and this is 1/2 XY. Then it says check your answer by using a specific length and width for the Pease's garden. So this is the one that we just chose numbers for. So ideally we want to pick numbers that nicely divide by 3 and divide by 4 so that we don't have any weird decimals or anything like that. So I'm going to go ahead and double check this and make sure that it works. And so a number that I can easily take 2/3 of is 9. Any number that divides by 3 nicely is going to work. And over here, any number that divides by 4 nicely will work as well. And so I'm going to go ahead and pick 12. So you could use your calculator and do 2/3 times 9. I know that that's 6. And you could take 3/4 times 12. And I know that that's 9. And now you're going to go ahead and you're going to find the area of each one. So it's 12 times 9. And this is 6 times 9. So obviously this one's 54. And so if I was just estimating this using this information, based on what I think up here, this is half the size of this. So if this is 54, this should be 108. So I'm going to go ahead and multiply the 9 times the 12. And sure enough, that's 108. Okay, and so this right here is half the size. So the numbers bear it out that our algebra up here with the variables was true. All right, so that's 17. Moving on to 18. So they're going to tell you to compute this in your head. I'm going to go ahead and show it on the paper, but because you were doing this in your head, there's no work that you have to show on your homework. But for part A, if I was computing this in my head, what I need to think about is that 5/3 is being multiplied times 3b, but 3b is really over 1. Again, this is supposed to be done in your head, but I'm visualizing a 1 underneath of this, which means that these 3's can just cancel each other out, which means there's really nothing left on the bottom because of the 1. I don't need a 1 on the bottom of a fraction, and so all that's left here is just 5b. For part B, 9 over x, I need to imagine x over c when I'm multiplying over 1. And so again, these x's are going to cancel, leaving me really nothing on the bottom. And so when I multiply it straight across, it's just 9c. Letter C. Imagine the other one as a fraction, so b d over 1. So the b's are going to cancel, really nothing left on the bottom. And so this is just a times d. And letter D. N squared is really over 1. You're imagining that in your head. A over n squared. So if you picture this over 1, you know those n's cancel out. And that final answer then is just A. Okay, 19. Combine and simplify. So the trap we don't want to fall into here is using the same skills or same tricks and tools that we were using for multiplication for addition. So we cannot start canceling anything from the top to the bottom right now because right now this is addition. So first of all, when we add two fractions, we always have to have a common denominator. We've already got that. Okay, so it's the same thing. So when you add two fractions that have the same denominator, it's just going to be something over n. So you could write this all the way out if you wanted to as just one expression like this. But the -5 and the +5, it's going to give you 0. They're going to cancel. This is like a -5 and a +5. So the only thing left over on top is 4n. And then using our skills now that we have a fraction, we can simplify it. These n's are going to cancel each other out. And so the only thing left is 4. Number 20. Multiplying all these, so anything on the top can be canceled with anything on the bottom. So A cancels A, B cancels B, C cancels C, everything cancels, and we need to know when that happens. The answer is just 1. 21. So I see a couple things here. First of all, let's deal with the letters first. Let's get them out of the way. There's 3 R's on top, and there's 4 on the bottom. So these 3 are going to cancel 3 of these. But since there was 4, that means there's 1 left over. So I'm going to have an R here on the bottom. S cancels S, and the rest are numbers. Okay, and this is a negative times a negative. So don't even worry about that with your canceling. A negative times any negative is going to be positive. So my final answer is going to be positive. Now, I can go ahead and start simplifying if I want, or I can multiply across and then simplify later. Either way is fine, but I see the 30 and the 120, and I know those are big numbers, but if you imagine them without the zeros for a second, it's a 3 and a 12. Okay, and we could simplify a 3 and a 12, and when you add the zeros, it doesn't change anything. So 30 and 120, you're technically dividing those by 30, or if it was 3 and 12, you're dividing them by 3, and so this becomes a 1, and then this becomes a 4. 30 goes into it 4 times, or 3 goes into 12 4 times. And then with the 28 and the 7, those can be divided by 7. So 7 goes into 28 4 times. 7 goes into 7 1 time. Now I have a 4 and a 4. I can continue to cancel. I don't need to come over here and put the 4 and the 4, although you can. But the 4 and the 4 are going to cancel each other out. Technically, they become a 1 and a 1. So everything's a 1. All my letters have canceled. Okay, I can't leave the top of a fraction blank, so I do need to put that 1 up there. But this is my final answer, 1 over r. Now, let's say you multiplied these straight across. So let's say you had the 30 times the 28. You would have got 840 on top. And then 7 times 120. You would have got 840 on the bottom, and then that, of course, is just 1. So those would have canceled each other out, and you would have been left with that r on the bottom, and so you would have left it as 1 over r. So just another way to think about it. All right, and 22. So right away, I want to go ahead and put this over 1 so I don't get that confused with anything. As I take a quick glance through this problem, I see that all of my variables are on top. So none of my variables can cancel. They're all going to end up here in the end. And this is a y and a y, so it's being multiplied times each other. So this is going to be a y squared, and the z is still going to be there. So let's see what's going to end up happening here. If you wanted to go straight across with just the multiplying and don't simplify early, first of all, it's a negative times a positive, so that will give me a negative answer. And 2 times 5 gives me 10. On the bottom, 3 times 6 gives me 18. So if I'm not going to go ahead and simplify anything early, then I know I'm going to end up with something that needs to simplify later. So if I wanted to, I could go ahead and use my fraction button and put the 10 over the 18. And that's going to give me 5 over 9. And so this is going to be negative 5y squared z over 9. And that's our final answer. That doesn't get simplified anymore. But what I could have done early is I could have seen the 2 and the 6 and knocked those down, dividing by 2, and that would have been a 1 and a 3. And then when you multiplied here, you would have got 1 times 5 is 5, and 3 times 3 is 9. So it really doesn't matter which way you like to do it. Just find what works for you. Okay, 23. Find two algebraic fractions whose product is this. So product means the answer to a multiplication. So I'm going to multiply two fractions, and they are going to equal 36a squared over 5x. So you can come up with whatever you want. You could have a bunch of x's on top. Make sure you have enough x's on the bottom so that when they cancel out, you're left with 1 on the bottom. I'm going to make it simple. I'm just going to put an x down here, and I'm not going to put any x's up here. Now, a squared, if you wanted to, you could put an a squared at the top of one of these two fractions, or you could be cute and put a, and then you're going to multiply them and you get that. To get 36, maybe you have a 6 here and a 6 here. And then on the bottom over here, maybe you have a 5. And if I multiplied straight across, 6 times 6 is 36. A times a is a squared. X times 5 is 5x. And so these are my two answers. Now you can come up with any two as long as when you multiply your two fractions together, you get this. That's what they're looking for. All right, 24. I can fit this one on here. So I'm going to go ahead and just simplify these in the calculator real quick. I think that's the easiest and most efficient way to do it. So I'm going to pull up my calculator function and do 110 over 130. And that's 11 over 13. For B, bring up my fraction button. 121 over 143. It's 11 over 13. And so we're going to do C and D. We're going to see which one is not equivalent. Now I can already see if this was 121 over 143, it's never going to equal 121 over 169. So that's not going to work. So 121 and 169, when you go ahead and you simplify that, it doesn't simplify. So that one stays. So clearly that's the right answer there. That's the one that's different. But just to finish it out, if I did 550 over 650, I get 11 over 13. And so the one that does not belong, the one that's different, is letter C. All right, we had 17 to 24. And so next on our list here would be 26. So it says if 5% of a number is 12, so 5% of some number is 12, what is 12% of that number? What is 12% of, and now we need to fill this number in with this. So those are kind of like your two separate ones. You could have done it one at a time and even ignored this until you figured this one out. So if I went ahead and I figured this out, 5% of something is 12. So I'm going to do 12 divided by 0.05. And it's 240. So up here, x is 240. So 5% of 240 is 12. What's 12% of that same number? So 12% of 240. What is 12% of 240? So I'm just multiplying. And it's 28.8. So just two steps right there. All right, 27. We're going to go ahead and solve this. Anytime you're working with an equation and something can be simplified on the left or the right side, that's the first thing you should do. So I'm going to go ahead and put these together because they both have an x. They're a like term. So the 150 plus the 200 is a 350x equal to 14,000. If I'm solving, that means I'm isolating the variable. So I want to get x by itself. 350 divided by 350 is 1, so I'm left with x. And now I just need to divide the other side. So 14,000 divided by 350, and it's 40. All right, 28. We just need to state the reciprocal of each. So remember, reciprocal is just the flipped fraction. So for letter A, 5. Well, that's really 5 over 1. So the reciprocal is 1/5. Letter B, 1 over 100 is going to flip to 100 over 1, which is just going to be expressed as 100. We don't need the 1 on the bottom. And letter C, negative 2/3. When you flip that, maybe you brought the negative with it. Maybe you flipped it and went like this. But that doesn't change anything. That's equal to, normally when you write it, you don't write it with the negative at the bottom. Okay, so I'm going to write this as just negative 3/2. You could put it on the top or you could put it out in front. Either way, there's the reciprocal, just flipping the fraction. The negative stays a negative. All right, we got 29 and 30. All right, 29. So your single-story house is to be built on a 75-foot wide lot, and you can see that right here in the picture, by 100 deep. So your lot goes 75 feet across, 100 feet deep. And then they give you all these different stipulations. The house must be set back 25 feet. It's got to be at least 20 feet from the back line. It needs to be at least 10 feet from each side. Now, if that just kind of confused you in the reading, you can just look at this right here. Everything's expressed here. It's got to be 10 feet from each one of these sides, 20 feet here, at least 25. Okay, so it could be farther. It could be 40 feet from the front, but the minimum is it has to be at least 25. So it says, what's the maximum area the house can have? So the biggest they can make this is if it was exactly 10 from here and 10 from here and 20 from here and 25 from here. It can make it smaller and still fit these stipulations, but we want to know what's the maximum area, the biggest house we can have here that still fits all of this. So if this is 75 across, okay, I'm taking 10 off here and 10 off here. So 10 off here makes it 65. And if you take another 10 off 65, that means, this is number 29, that means across the top of this, 75 basically minus 10 minus 10 minus, so that's minus 20. That's going to be the maximum of 55. And then going this way, that's 100 feet, but we got to be at least 20 feet from here. So that leaves us with 80. And then if we take 25 away from 80, that leaves us another 55. And so it's 55 by 55 at a maximum. When you want to find the area, you're just multiplying the two sides. So 55 times 55. And so the biggest that this can be is 3,025 square feet. Okay, last problem. It says consider 3/4 divided by 9 over 32. Part A, rewrite this as a multiplication. So when we rewrite this as multiplication, we leave the first one alone, we change it to multiplication, we flip the second one. Okay, so there's your first answer. What's the answer in lowest terms? So you could go ahead and you could multiply these two across. Now you can use some of our new skills. 3 and 9 are going to cancel. Divide those by 3, you get 1/3. 32 and 4 can be divided by 4. So 4 divided by 4 is 1. 32 divided by 4 is 8. And so now when I multiply, it's 8/3. Again, you could have just multiplied straight across. So 32 times 3 would have got you 96. And 4 times 9 would have been 36. And then when you wanted to simplify that, you're going to go ahead and punch it in. So you've got 96 on top and 36 on the bottom. And that'll get you all the way down to 8/3. And then part C, what's the answer as a decimal? So how do I turn 8/3 to a decimal? We're just reminding ourselves how to do that. That's division. So it's 8 divided by 3. And so we get 2.6 repeated. And don't round it. Actually express it as the full thing, 2.6 repeated.